Okay, so today we're doing 2-2, and because functions and relations was so fun yesterday, we're going to continue with functions and relations. This is just the second part of functions and relations. And notice we're starting out by focusing in on the coordinate plane. So what I want you to do is right here in your notes, right here you have a coordinate plane. You have to draw on here what the origin is. Somehow show me here what the origin is. And then over here, what I want you to do is write in, I'm going to type it, or write in verbal description. So you can just write that in. I'm going to shrink this down a little bit. You should be writing while I'm shrinking. Okay, so this is going to be a verbal description of what the origin is, or whatever this word is right here. Okay, so I'm going to do one with you, and then you're going to do the rest on your own. So right here, origin. What is the origin? How can I show what the origin is? Well, hopefully you know. The origin is right here. Label it on the graph. Well, that was bad. You know, I got my little tablet. It still has issues sometimes. Okay, so that's your origin. That's an I. I don't know why it keeps doing that. Okay, origin. And the coordinates of my point right there are 0, 0. And my verbal description might be the center of a coordinate grid or coordinate plane, coordinate graph. My eyes keep connecting. I don't know why. Okay, the center of a coordinate graph. A coordinate graph is a 2D graph. In case you don't know what a coordinate graph is, it has an x and a y coordinate, or I'm sorry, axis, where a number line is just one dimensional. It just has one line. You could say x equals 0, y equals 0. Just put it in your own words so that you understand what the origin is. And so go ahead and do that for ordered pair, and do that for the rest of these. Okay, again, pause the video if you need to. We're going to go on to function notation. Functional notation is a method used to represent the point xy as x, f of x. So really, you're just, instead of writing y, you use f of x. Don't let that confuse you. Whenever you see f of x, try to just think, oh, that's just a y. F of x just means y. Other letters besides f may be used in order to identify multiple functions by different letters. Like you might say, if you look down here, you might have g of x, which still means y, and h of x, which still just means y. So this just really just says y equals x squared plus 2. This says y equals 4x plus 10. But up here we're going to use f of x. So this says y equals 2x plus 3. Find f of 4. So what this means y, but f of 4, you're thinking, okay, what this really means is find y when x, see how this is x? So this is your x. This 4 is your x. Find y when x is 4. Okay, so if we're going to find f of 4, and x is 4, we're just going to take out this x right here, and we're going to put in 4. 2 times 4 plus 3, so f of 4 equals 8 plus 3 is 11. If I show good work, I'm a good math communicator. I would just write it like that. Okay, and then find f of negative 1. So find y when x is negative 1. So f of negative 1. Again, we're using the same function, 2x plus 3. We're going to take out the x, and we're going to put in negative 1. So this is negative 2 plus 3. F of negative 1 is 1, because negative 2 plus 3 is 1. So the ordered pair right here for, that's my x, and my y, f of x means y, f of 4, my y is 11. Fill in this one. And hopefully you said your x is -1 and your y is 1. So given that g of x, now it's the same thing. We're just using g instead of f. Don't let that confuse you. In that g of x equals x squared plus 2, and h of x is 4x plus 10, this is just another function. This is a function. This is a second function. Evaluate the following. H of 3. Well, since it says h, we're going to go to here, and our x is 3. We want to know what is y when x is 3. So equals 4, take out the x, put in 3, and the parentheses just means times. When the parentheses, it just means times. So if you don't like putting the parentheses, you can use a dot to mean times. Plus 10. So 4 times 3 is 12, plus 10, hopefully you said it's 22. So h of 3 is 22. That's my answer. This is 22. Okay, g of -3. So now we're going to use g, we're going to use this function, and we want to know what is y, or g of x, when x is -3. So we go -3. Now here, I cannot stress this enough, it's very important that you take -3 in parentheses squared, because the -3 is taking place of this x right here. So put it in parentheses. Now it's really important, especially on your calculator, that you put it in parentheses, because -3 squared really means -3 squared, like this, if you don't put the parentheses in the right place. And this would be -9. But what we're trying to do is take the x, which is -3, multiply it by itself, so it has to be -3 times -3, which this would be a -9, this would be a +9. And again, all year long last year, people were doing this, or they were just leaving it like this on their calculator, and they would get it wrong. So don't do this if you're supposed to square. There are situations where this is what it means, but right now it means take the -3, times it by itself, and square it. So put it in parentheses on your calculator if you're using your calculator. So plus 2, that's over here, plus 2. So we get negative times a negative is a +9. And I'm writing a positive to exaggerate it. You don't need the positive. Plus 2 is 11. So g of -3 equals 11. Okay, what about this? A plus 1. Wow, that looks complicated. But really, we just take out the x, see where the parentheses is, and put in the a plus 1. So we're going to take a plus 1 and square it, plus 2. Now we could simplify it, but right now I just want you to be able to get to this point. I mean, later you'll learn how to take a plus 1 times itself, and it really means this. And if you did remember FOIL from Algebra 1, or maybe you did it in geometry, FOIL, or you can make a box, you'd go a times a is a squared. So this one times this one, and then you would have to take a times 1, which is a, and then you would have to take 1 times a is a, and then 1 times 1 is 1. So it'd be a squared plus a plus another a, which is 2a, plus 1. So it'd be a squared plus 2a plus 1 plus this other 2, and then you'd simplify. But for the sake of what we're doing right now, let's just leave it like that. Just don't ever do a squared plus 1 squared. That's not what that means. Okay. In function notation, f of x, which symbol represents the domain and range? Well, the domain is their x's, and the ranges are y's, but we're not using y anymore, we're using f of x. What are the benefits of using function notation? Okay, so write some answers. Write what you think would be the advantage of using function notation. These answers can vary. There's no really right or wrong. It's what you think are the benefits. Okay, so answers might be, I think the f of x really shows that your y depends on your x. Your f of x or your y, and I'm just going to write in parentheses f of x, the y or the f of x depends on x. So it's a function of x. Okay, what's another reason for function notation? Some answers might even be just like, oh, it makes me feel smarter, because look how complicated that looks compared to just using y. What are some other things like, um, you might write some other things. Again, answers may vary. The main thing is that this shows that your y is a function of x. It depends on your x. I think that's the main advantage. Oops. Okay. Okay, so this is an exit ticket. Okay, let's look at this one. This is the same as yesterday. Let's identify the domain and range and talk about your discrete and continuous and some things we talked about yesterday. Now, notice though, this is a graph versus a list of points. So when you're doing the x values, or your domain, because remember your domain is your x values, this is how my students understood it last year. What I told them to do is pretend like they're walking along from left to right, and what is the first x you hit? Well, the first x you hit is -2, but it's not included because it has that open circle. So this is called interval notation. So we're going to write open parenthesis when it's an open circle. This is an open parenthesis, and we're going to write -2, comma. That's the first x we hit. Well, we followed this little path, and what's the last x we hit? Well, the last x we hit would be 1, 2, 3, 4. And because it's a solid filled in dot, it's included in this graph. This one's open, it's not included, so we put an open parentheses. When it's included, we put this is called a closed bracket to show that the 4 is included, but the -2 is not. Now, there's a second way you need to know. This is called interval notation, and the other way is just inequality notation, and you also need to know inequality notation. So inequality notation looks like this. You write -2 is less than, your arrows will always point to the left because your lower number goes to the left, the arrows point to the smaller number, and we're doing x because it's domain. If it were range, we would be doing y. And then less than or equal to. Now, why did I put equal to here? Because it's a closed circle, the 4 is included. The -2 is not included, we don't put the little equal to sign. So this is called inequality notation, and this is called interval notation. You need to know both. Okay, let's do range. I'll do it in blue, and the range is our y's. So now, instead of walking along side to side, because x's go side to side, you need to start from the, let's start from the bottom, because think about if you're flying in an airplane, or you're, let's see, if you're flying in an airplane, you start from the bottom and go up, or if you're climbing stairs, you start at the bottom and you go up. So let's start at the bottom and you go from the smallest to the largest. So as we're going up, what's the first y value you hit? Well, it's right here. If we were floating, like let's say we had a big airplane and it's raising up, what's the first y value it hit? It's this one, and it's -1, 2, 3, 4. So -4, and it's a solid dot, and so we're going to put a closed bracket to show it's included. And then if you're floating up, what's the last y value you hit? Well, right here. And it's +3. And again, it's included because it's a solid dot, so we use a closed bracket. That's called interval notation. But we also have to do inequality notation. So you write -4, the smallest number first. The arrows always point to the left. We're going to put equal to because it's a solid filled in circle. And then now we're going to use y instead of, because we're doing range. And then less than or equal to, the 3 is included, so we use the equal to sign here. And that's our inequality notation. Is this relation a function? Is there anywhere we could draw a vertical segment anywhere? Can you draw a vertical straight up and down segment between any 2 points? No, so yes, it's a function. If you can draw a vertical segment, think, oh, that's bad, it's not a function. Is it continuous or discrete? Well, because you can draw lines and it's a graph that continues, notice it starts here and it continues on this whole interval, it's called continuous. And on what interval is it increasing? Okay, now this is a little tricky. We're going to write, again, we're going to use interval notation and inequality notation to show where does it increase. And you read a graph like a book. It goes from left to right. You read from left to right. So it makes sense that when it's increasing, it goes uphill, and when it's decreasing, it goes downhill. So where does it go uphill? Well, it goes uphill right here, starting at, and you tell in terms of x. So we're going to use our x's. And same with decreasing x's. So our x's are from -2, not including -2, to it stops increasing at where the x value is 0. And it doesn't include the -2, but it does include the 0. And then also it's increasing right here. Notice we fell. Ooh, it's going down. It's decreasing right there, but it's increasing again right here. It's going uphill from left to right. So here our x value is 1, 2, and 2 is included because it's a filled in dot, to 4. And that's interval notation. If we were to write inequality notation, I'm going to write it down here. It would look like this. It would be -2, less than x, less than or equal to 0, and 2 less than or equal to x, less than or equal to 4. Okay, where's it decreasing? Now it's decreasing. I'm going to do that in green. I'm going to switch colors here. Let's do it in green because we're going to use green. So right here it's decreasing. This is where it's going downhill. And our x value is 0. And here our x value is 2. So from 0 to 2, it's going downhill. Woo! Downhill. So from 0 to 2, it's decreasing, and inequality notation would be 0 less than or equal to x less than or equal to 2, because those are closed circles. Let me try to make this 2 better. There we go. It's more like a 2. Well, let me grab it. There it is. Yep, and they're both closed circles, so it's closed brackets. Okay, so try the next one. Identify the x values. Okay, so our x values, we're walking along from left to right, and the first x you hit is a 0. And it's a closed circle, so it's a bracket. And guess what? It goes forever and ever and ever and ever and ever, so we say infinity and beyond, to infinity and beyond. Now I put an open one because it can never touch infinity, because we can't ever touch infinity. And our inequality, now our inequality is a little tricky. You wouldn't write 0 to infinity. You would just write, well, x is greater than or equal to 0. And then the range is your y values. And start at the bottom, pretend like you're floating up in the air, a big old line going across here. What's the first y value hit? Well, our first y value here is 0. Closed circle, closed bracket. And again, it keeps going up and up and up and up and up and up and up forever. So we say 0 to infinity. And so our y is also greater than or equal to 0. Is a relation a function? Can you find a vertical line? Can you draw a vertical segment anywhere? No, so yes, it's a function. Our x's don't repeat. Is it continuous? It's a line or smooth curve, so it's continuous. On one intervals is it increasing? Well, it's always increasing. If you go from left to right, notice it's always increasing. There's no downhill. So it increases from 0 to infinity. That's interval notation. Inequality notation for x greater than or equal to 0. And then, is it decreasing? It's not. So you can just say does not decrease. Okay, and that's it. We're not going to do these, and that's the end.